Okay, so this lesson is on average value, which we can get from a formula. So I should write it up here. This sheet was handed out in class. Okay, so all right, the average value of y equals f of x over some interval AB equals this. It equals the integral from a to b, we'll use t, f of t dt all over b minus a. Okay, so guys, I want to be clear about this. A lot of time, or usually when we are taking the integral of something, we will integrate a rate because that will give us the net change. But in this case, you're not putting the rate of f in here. Whatever you want the average value of, that's what you put in the integral, whether it's a rate or not. And then you divide it by the time interval. Okay, so the amount of people in Wegmans on a given day is modeled by the twice differentiable function w of t, where w of t is measured in people and t is measured in hours. So part A, write an expression for the average rate of change of the amount of people in Wegmans from t equals 2 to t equals 6 hours without using an integral, Okay, and then part B, I'll read it right away. Write an expression for the average rate of change of the amount of people in Wegmans from t equals 6 to t equals 8 hours using an integral. Okay, so there's two ways to do this. So first, you've got a derivative sequence. Okay. And people, okay, so the units here are people per hour squared. Now let's figure out where w of t falls within this derivative sequence. And guys, it's actually right at the beginning. Okay, so that's w of t. So in this column, we would have w prime of t, w double prime of t. Okay, so guys, this is AROC. So if you're trying to find AROC of w, okay, so AROC of w, that's going to give us the average rate of change. So the units are going to be moving over 1. And without an integral, it goes like this. It goes w of 6 minus w of 2 over 6 minus 2. That's it. Okay? And guys, notice the values up here are people, and then 6 and 2, those are time values. So people per hour. So we use w, but we got people per hour as our units. Okay, so that is the average rate of change of, the amount of people in Wegmans over that time interval. Now B, if we wanted to use an integral, okay, we would actually have to start, if we want to use an integral, we would do this formula here on the rate function. So it goes like this. It goes the integral, this is the second one, 2 to 6, from 6 to 8, w prime of t dt over 8 minus 6, which would be 2. And guys, notice the units on this. So just look at the top for a moment. This is net change. We're integrating a rate. So if you integrate a rate, if I take this rate and I integrate it, my units are going back 1. So the top here is people. All right. So, but then since we divide by the time interval, which is in hours, we do end up with people per hour. Okay. So this is an expression for, the same thing that we did in part A, but using an integral. All right. We'll practice that more in class. Now this one. So the rate at which water is flowing into a tank in gallons per hour is modeled by the differentiable function given below. Find the average rate at which the water flows between 0 and 3 hours. Okay, so first let's figure out where we are in the derivative sequence. So F prime, F double prime, gallons. Okay, the rate at which water is flowing in gallons per hour. Okay, so R of T is actually right here in the middle. Okay, so we're starting in the middle of the derivative sequence. So this already is a rate. And now they want the average rate at which the water flows. Well, guys, if you've already got the rate and you want average rate, that's when you use this formula on the rate. Okay. If you want average rate, but you don't have the rate, you have what comes before it, that's when you would do like part A. Okay, so anyway, okay, so this is basically, this is the average value of R of T on 0 to 3. Okay, so the average value of R of T on 0 to 3, and this is optional, like notation, is equal to, it's not even real, like proper, the integral from 0 to 3, whatever you want the average value of, that goes in here, R of T dt, divided by 3 minus 0, which is 3. Okay, so this we will use our calculator for. So this is the integral from 0 to 3 R of T dt divided by 3. Okay, so we get this. Math 9. 0 to 3. R of T is sine x to the third minus 3. And then you have to divide that whole thing by 3. Okay, and then we end up with that. Oh, I messed up. Sorry. It should be, the parentheses should close there. And then minus 3 on the outside. Okay, whoops. Okay, so this is equal to negative 2.845. And the units, for average value, I know that you use an integral, but because you're dividing by time, the units don't actually move. So if you're doing average value in the middle of the sequence, the units, that's what the units are. Gallons, per hour.